Hi everyone! Today let's talk about section 11.8, length of curves. If the position of a moving particle at time t is given by the function gamma of t, then the distance that the particle travels from time t equals a to time t equals b is found by integrating the speed. So the length of curve from t equals to a to b equals the definite integral from a to b of the speed. So here is a way to think about why this is true. Imagine we partition the curve into pieces. If the pieces are small enough, then each piece is approximately a straight line segment. Okay? So we partition into small pieces. Okay, then each piece is like a line segment. Okay, of course, if we partition more and more pieces, then the curve is very good approximated by the line segments. So consider one small piece, and suppose it takes the particle t unit of time to travel along that portion. If that portion is small enough, it is approximated by the displacement vector. So this is a displacement vector, change of gamma equals gamma of t plus change of t minus gamma of t. So we call the linear approximation change of gamma equals gamma prime of t times change of t. So the approximating length of this segment equals the length of the velocity times change of t. And then when we sum them all up, we get the integral of the speed change of t. Okay, so this sum becomes the integral, and then we have the speed, and then d of change of t becomes dt. And also, in chapter 10, when we talk about parametric curve, okay, so in section 10.1, we also talk about the length. Suppose we have a parametric x is x prime of t, y is y prime of t, then the length is from a to b, x prime of t squared plus y prime of t squared dt. And in R2, this is exactly the speed. Okay, so in R2, this is exactly the speed. So in R3 or Rn, when we have more components, well, we just have more coordinates, right? Maybe u plus z prime of t squared there. Okay, and then for polar curve, this is the outline for a polar curve. We have the r is f of theta, so we have f of theta squared plus f prime of theta squared. Okay. So let's look at our example. Find the length of the portion of the helix chased out by cosine t, sine t, and t from the point 1, 0, 0 to the point 1, 0, 2 pi. Okay, so here, first of all, let's find the velocity. So what does the helix look like? Well, let's try to plot it. So when we plot it, cosine of 0 is 1, sine of 0 is 0, t is 0, 0. Okay, so 1, 0, 0. So this is the point when t equals 0. And when t equals pi over 2, cosine pi over 2 is 0, sine pi over 2 is 1, t is pi over 2. So this is the point, okay? And then when t increases, we just have this helix wraps around like that. Okay, so this is the helix. So what is the velocity for it? Derivative of cosine is sine negative sine t. Derivative sine t is cosine t. Derivative t is 1. Then what is the speed of that? Square root of sine t squared. So each component squared. So sine t squared, cosine t squared, and we have the 1, right? So, well, we know sine plus cosine equals 1. So this is just square root of 2. Well, then the outline is integral. So for the point 1, 0, 0, that corresponds to t equals 0. For the point 1, 0, 2 pi, that corresponds to t equals 2 pi. So we evaluate the t from 0 to 2 pi of our speed. Speed is square root of 2. Well, this is just integral of constant function is just square root 2t. Evaluate from 0 to 2 pi. So which means we plug in 2 pi first, subtract, we plug in 0. So we have 2 root 2 pi is our final answer. So far, so good, everybody? Okay, next, set up an integral for the length of an ellipse. And don't need to evaluate. Okay, so first of all, we want to find a parameterization for it, right? What is the parameterization for an ellipse? Well, we can consider this is x over 2 squared plus y squared equals 1. Then we have x over 2 is cosine t, y is sine t, then x is 2 cosine t, right? And then this is in R2, right? So our curve, our parameterization equals 2 cosine t sine t. And then what is the velocity? Well, derivative of cosine is minus sine. Derivative of sine is cosine. Then what is the speed? Well, the speed is going to be the first coordinate squared. 2 squared is 4. Sine squared. And then we also have cosine squared. Well, if we can simplify a little bit, we can split the sine squared, 4 sine squared as 3 sine squared and a sine squared. But why? Because you can use the sine squared coupled with the cosine squared will give us 1. So this is 3 sine squared plus 1. See, there's only one trig function. It's not like 2 trig function there. So it's easier than before. So our length, because it's the whole ellipse, with this parameterization, so because 2 is in the denominator under the x, so 2, 1, 2, the major s is on the x-axis, so, and then the minor s is 1. This is the ellipse. And then when t equals 0, we are at this point. When t equals pi over 2, we're at this point. This is when t is pi, when t is 3 pi over 2. And when t is 2 pi, we get back to this point. So the whole ellipse goes from 0 to 2 pi. And then we have the 3 sine squared plus 1. Okay, dt. So this is the outline, okay? You know, after calculus 2, we understand that for derivatives, any given functions, we can differentiate it. But unlike integrals, there are so many functions we're not able to find the integral of it, and right, so this is one of them. So this is square root functions, and we cannot use the integration techniques that we learned, like use substitution, integration by parts, trig integrals, trig substitutions, partial fractions. So none of the techniques can help us to integrate this. So but however, we can use some numerical methods. So numerical integrations can help us to approximate this integral as close as we want. Okay, which we don't cover in this course. But if you, in the future you're gonna take the CS 3500 numerical methods, we will talk about that in that class. Okay, so here don't need to evaluate, just leave it here and let's continue. Or if you're interested to know, you can go to my website. I'm teaching that course as well, so you can see the session about numerical integration. Okay, next example, find the arc length of the cardioid. R equals 1 plus cosine theta. Okay, so let's go back. What is the formula? Keep in mind, square root of the function square plus the derivative of the function square. So here we have the function 1 plus cosine theta. What is the derivative? Derivative of 1 is 0. Derivative of cosine is minus sine theta. Then we have the arc length is the cardioid. Okay, so what is that? Let's draw it. So when theta is 0, we get cosine 0 is 1. 1 plus 1 is 2, is right here. And then when theta is pi over 2, cosine pi over 2 is 0, we get 1 right here. When theta is pi, we get cosine pi 0, so we get 0 here. And actually, because this guy and this guy, they kind of like a mirror image. Okay, so that's why here it will be similar to that. Okay, so the arc length, you can calculate the theta from 0 to 2 pi, but because the upper half and the bottom half is going to be the same, because it's symmetry, right? So in order to calculate from 0 to 2 pi, you can calculate 2 copy of from 0 to pi. That will save us some work. Okay, now let's see. We have f squared, so 1 plus cosine theta squared plus f prime squared, which is sine theta squared. Okay, let's see what it is. So we have, let's distribute it, multiply out. Okay, so 1 plus 2 copy of cosine theta plus cosine theta squared plus sine theta squared, but every time we see sine squared plus cosine squared, that is 1. And then we have 2 plus 2 cosine theta. Okay, how can we continue? Well, because of the square root, if we want to calculate this integral, then we must find a way to get rid of the square roots. Otherwise, you either use substitution or we don't know what to do, right? So and here we can, so we either try to complete the square, or here this is about trig functions, then think about double angle formula. So in our course, double angle formula is so important. You will see it a lot. Okay, so please familiar with the trig identities and the double angle formulas. So double angle formulas, we have cosine square. Let me use t instead of theta because we already have theta here. So cosine square is 1/2 plus 1/2 cosine 2t. Sine square is 1/2 minus 1/2 cosine 2t. Here, which one we should use? Well, because it's plus in the middle, we should use this. And because we have 2 plus 2, so let's multiply both sides by 4. We have 4 cosine t squared equals 2 plus 2 cosine 2t. Now compare. 2t is theta. Then what is t? Well, t is then theta over 2. So this guy is 2. And then we have square root of 4 cosine square of theta over 2 dt. What is square root of 4? Well, that's 2. We can pull out the 2. 2 times 2 is 4. And then square root of cosine square will give us absolute value of cosine theta over 2. You cannot just You cannot just get cosine theta over 2. It's actually absolute value of that. So let me put it here. Square root of a squared is absolute value of a. Okay, why is that? Think about negative 2. Well, negative 2 squared when you take square root, well, that's square root of 4. So you see, it's 2. It's not negative 2. So it's the absolute value of negative 2. Okay, but look at the angle when theta goes from 0 to pi. Theta over 2. Okay, so when theta goes from 0 to pi, theta over 2 goes from 0 to pi over 2. Well, look at the cosine. From 0 to pi over 2 is always positive. Because it is always positive, now it is okay to forget about the absolute value. So this is how we break the absolute value. Okay, we break into pieces. If the function is above the TS's or the XS's, then we add it at the integral. If the function is below, then we subtract the integral because an integral will be negative. Okay, let's see, do I have enough space here? Integral of cosine is sine theta over 2, but because you want to divide by 1/2, it's the same as multiply by 2. And then evaluate from 0 to pi. Oh, my pi looks like very under the 2. Let me put it here. So this is 8 sine of pi over 2 minus sine of 0. But sine of pi over 2 is 1. So the final answer is 8. So far, so good, everybody. So I really hope that you can review all the trig identities. Let me show you here. So on my website, if you click Calculus 1, and then you can see all of my class worksheets and the videos and the notes with answers. So here I give you some algebra formula sheets, trig formula sheets, and calculus formula sheets. Okay, so a lot of formula sheets, please go over all of them and make sure you kind of know what are those formulas. For some common use formulas, please memorize them. Okay, because we're building a house, we have to make sure we have a good foundation, then we can build more and more levels on top of it. And then you can click this note with answers for the 1.1. Okay, so click this note with answers, then when you go back to the last page, I introduce this hexagon. So you draw the order you write down the function is the natural order when you say those 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant, and then you put 1 in the middle. Okay, and then look at the diagonals. There are 3 diagonals. So for the diagonal formulas, the product of the 2 ends equals the middle one. So let's look at this diagonal. We have sine times cosecant equals 1, and then look at the second diagonal, from the right upper corner to the left lower corner, we have cosine x times secant x equals 1. And for the horizontal diagonal, we have tangent times cotangent equals 1. And then you can see there are 3 upside down triangles. Well, the rule is the sum of the square of the upper 2 vertex equals the bottom vertex square. This is not a Pythagorean theorem. This is just a trick that I use can help us to memorize the trig identities. So for the top triangle, we get sine squared plus cosine squared is 1. The left lower triangle, we get tangent squared plus 1 squared is 1, right? Tangent squared plus 1 is secant squared. For the right lower triangle, we get 1 plus cotangent squared is cosecant squared. And also keep in mind that tangent equals sine over cosine. Okay, so that's the trig identities. And also double angle formula. sine 2x is 2 sine x cosine x. Cosine 2x is 2 cosine squared minus 1 equals 1 minus 2 sine squared. So we also have cosine squared is 1/2 plus 1/2 cosine 2x. Sine squared equals 1/2 minus 1/2 cosine 2x. So keep these in mind. Then I would say this is a trig formulas we need, and also the trig graphs. You need to be familiar with the sine and cosine, so be familiar with the sine and cosine, and all the rest you can deduce from it, because tangent is sine over cosine, cotangent is 1 over tangent, secant is 1 over cosine, cosecant is 1 over sine. And then keep in mind that 1 over 0 is undefined, but you have a vertical asymptote there. 1 over 0 plus is infinity, 1 over 0 minus is minus infinity, 1 over infinity is 0, 1 over minus infinity is also 0. Okay, so keep those in mind. You can deduce the graph of tangent, cotangent, secant, cosecant from the graph of sine and cosine. And for the inverse trig functions, well, you just pick a piece that is 1 to 1, and then you think about the x values of the inverse. Let's say the x values of the arc sine corresponds to the y values of the sine. Okay. So far, so good, everybody. All right. So this is sessions 11.8. Have a nice day. Bye.